Hello friends, in this lecture we are going to learn about Common Modulus Attack. It is also a protocol failure attack on RSA. First one we learnt about was the low exponent attack, the low public exponent attack, and now this one, the another one is Common Modulus Attack. Okay, so RSA is a commonly used public key crypto system, as we all know, and is very secure if and only if you use sufficiently large numbers for encryption. Okay, so consider a scenario where a person called Alice encrypts same plain text, same message, okay, and sends it to two different people. For example, C1 is equal to M1 raised to E1 mod N, and C2 is equal to M2, sorry, this both will be M because he sends the same message, E2 mod N. Okay, so Alice encrypts the message, same message M, two different times, which he sends to two different people. So suppose you eavesdropped on the communication and got both the ciphertexts C1 and C2 and the exponents used E1 and E2 as well. If you remember, in the low exponent attack the E was the same. In this common modulus attack the M is same. Okay, so you got ciphertext C1, C2, you got the exponents E1 and E2 Alice used, and you already know that the common modulus N is same and it is public as well. Okay, so there is a way that you can decipher it. So in order to do that, you can use extended Euclidean algorithm 1, and also what you need to check is that you have to check whether the GCD of E1 and E2 is equal to 1 or not. Okay, if it is 1, then you can move ahead. So let us move forward with the formulas. We have to remember some formulas to solve the sums for common modulus attack. So first one is A1 E1 plus A2 E2 is equal to 1. Okay, so now how you can find the messages? So to find the message, the formula is C1 raised to A1 into C2 raised to A2 mod N. Now C1 we all know is equal to M raised to E1 and C2 is equal to M raised to E2. You can check it over here. We have, so now if we put these values, we get the answer as M raised to E1 raised to A1 into M raised to E2 A2 mod N. You can also write it as M raised to A1 E1 into M raised to A2 E2 whole mod N, which you can also write it as M raised to A1 E1 plus A2 E2 mod N. And as we all know that A1 E1 plus A2 E2 is equal to 1, so this will be equal to M raised to 1 mod N, and you will get your answer as M. Okay, so now let us try solving it with an example where we have some particular numbers and all. Okay, so suppose we have N is equal to 143, E1 is equal to 7, E2 is equal to 17, C1 is equal to 42 and C2 is equal to 9. Now to calculate the values, to calculate the entire sum, we need two more values, that is A1 and A2. So how do we get it? So as I told you that we will be using two things to check this thing. So first I told you was the extended Euclidean algorithm, which also means multiplicative inverse, and the part 2 is GCD of E1 and E2. Okay, so this thing we have done. The remaining part is multiplicative inverse or the extended Euclidean algorithm. So what you will do is that you will take these E1 and E2 values to find the multiplicative inverse, and using that we will be able to get our A1 and A2. Okay, so for extended Euclidean algorithm, we have the method as QR1 R2 T1 T2 T. If you guys don't remember how to find multiplicative inverse, I'll provide you a link on the top right corner and you can watch the video for how to calculate the multiplicative inverse as well. Okay, so it will be 17, 7, quotient will be 2, remainder will be 3, shift 7 and 3, quotient will be 2, remainder will be 1, 3, 1, quotient will be 3, remainder will be 0, 1, 0. So whenever we get 1, we stop. Here initially it will be 0 and 1, and as we all know, to find the t, the formula is t1 minus q into t2. So here t1, 0 minus q into t2, 2 into 1, so 0 minus 2, minus 2, shift them. Again here we will get plus 5, minus 2, 5, and here it will be minus 2, minus 15, minus 17, 5, minus 17. Okay, we stop at the same level. So now what happens is that this value you get will always be equal to A1, and this above exactly A1 will be equal to A2. So you can note over here that A1 will be 5 and A2 will be minus 2. If you want to reconfirm that we have A1 and A2 correct or not, then we have a formula, right? A1 E1 plus A2 E2 should be equal to 1. So check whether is it 1 or not. So 5 into 7 plus minus 2 into 17. So 35 minus 34, it is equal to 1. So yes, our A1 and A2 values are valid. Okay, so now let us find the M, which is equal to C1 raised to A1 into C2 raised to A2 mod N, which will be equal to 42 raised to 5 into 9 raised to minus 2 mod 143. So what you can do over here is that you can do 42 raised to 5 into, here either you can do is that you can square the 9 and do the inverse, or else you can find the 9 inverse and the answer you get by doing the mod with 143, you can square the answer. So what we will be doing is that we will be doing 9 inverse square mod 143. So again we need to find the value 9 inverse mod 143. So again we will be using the extended Euclidean algorithm, the multiplicative inverse. So Q R1 R2 R T1 T2 and T. So our R1 here will be 143 and R2 will be 9. Quotient will be 15, remainder will be 8. Shift 9 and 8. 8 ones are 8, remainder will be 1. 8 1 1 is 8, remainder will be 0, 1, 0. Here initially always 0, 1, and as I told you, t is equal to t1 minus q into t2, so it will be minus 15. Shift 16, minus 15, 16. No matter whatever value it is, we are shifting 16 over here, right? So we know that our answer will be 16. So 9 inverse mod 143 is 16. So we substitute the value. So 42 raised to 5 into 16 square mod 143. So now by using our calculator, we will find 42 raised to 5 into 16 into 16, because we have 16 square. Oh, okay, it will not be allowed. So let's do it separately. 42 raised to 5 divide by our modulo 143. Subtract numbers before decimal. 913924 into 143 equivalent to 100, and we have 16 square, so 16 into 16 into 100 divide by 143 minus 179 into 143. So our m over here we found out using the common modulus attack. The message sent was 3. Okay, so this was all about the common modulus attack of RSA, also known as the protocol failure attack on RSA. Okay, thank you.